Hi, here we go. Lesson 4.6. We're going to be talking about slope-intercept form and how to graph a line using slope-intercept form. If you look at example 1, it says we're going to graph the line given two key pieces of information. And we can recall from our equation y equals mx plus b that our slope is our m value in the equation and our y-intercept is the b. So if we looked at this particular situation, we would see or should understand that the equation of this line looks like this. Y equals negative 2/5 x plus our b value, our y-intercept, which is 4. Now graphing this couldn't be simpler. We're going to start with b in the alphabet. B comes before m, so we're going to start with that. The y-axis is our vertical axis, and we're going to plot the point 4. After dealing with intercepts, we understand the y-intercept is when x is 0 and y is 4. And then we're going to take that information given in our slope, and we're just going to follow the directions. We're going to go down 2, followed by a run of 1, 2, 3, 4, 5. It's here that we will plot the second point. So first we locate a point which is b, the y-intercept. The next thing we do is follow the directions and do exactly as the slope says, rise, over, run. And we could see that our rise was negative. We went down 2, and then we ran 5. Of course, we would connect those points, showing the equation y equals negative 2/5 x plus 4, the linear function, in graph form. I'd like you to look at example 1. It says graph the line with a slope of negative 2. M is equal to negative 2. And a y-intercept of 4. Well, this is just as fast and easy. Remember, we always start with the b value alphabetically. It comes first. So we're going to plot that b value, which means x is 0, and we're sitting on the y-axis. Hence, its definition, y-intercept. So we're going to count up 1, 2, 3, 4. We're going to place that point. We understand that our slope is negative 2. We can rewrite that as a unit fraction. Any whole number is just over 1. So we're going to come down 2 units and over 1. And that gives us our second point. The first thing we do is plot the y-intercept. The second thing we do is use the slope to tell us how to get to the second point. And remember, it only takes 2 points to plot a line. Please do the Check It Out problems 1A and 1B and check with me for your solutions. Let's go ahead and look at the top of page 269. 269, those know it notes. That says you need to know this. Know it. So it says if a line has a slope m and a y-intercept b, then the line is described by the equation y equals mx plus b. We know this. This is review for us. I want you to look at example 2. It says write the equation that describes each line in point-slope form. We're just going to go over one of these, and then you're going to try it on your own. It says our slope is 1/3, and our y-intercept, or b, is positive 6. We're going to put a b out here. B, y-intercept. So we know these things to be true. The m value indicating slope, we're going to write out our equation. We're just going to replace that with our slope, 1/3. And please don't forget that variable x stays in the equation. And we're going to add to that our y-intercept, plus 6. Well, that seems easy enough, and that's because it is easy enough. This equation now tells me, if I were looking at it, that my y-intercept is 6. And my slope says, I plotted my b value first, my slope says to go up 1 and over 3. Now, positive 1 over positive 3, isn't that the same thing as negative 1 over negative 3? Both of those are positive, aren't they? So if we run out of space at the top of our graph, we can simply come down 1 unit, and we could go back 3 units. 1, 2, 3. Negative 1 over negative 3 is the same as positive 1 over positive 3. And when we finish graphing that with the two negative values, we can still see this graph has positive slope and a positive correlation as when we were dealing with our scatter plots. Please try check it out 2A, B, and C, and come check with me when you get those solutions. Example 3 says we're going to use that slope-intercept form to graph. We see the equation in example 3, part A. We're given the equation y equals 4x minus 3. One of the things I like to do when I'm graphing is to extract those parts out of the equation that I know I'm going to need. So I'm going to do this. I'm going to take my m value and label it, and I'm going to take my b value and label it, remembering always in the same order, plotting our b value first. This b value says, now mx plus b, our b value is negative 3. You need to pay close attention to that when you're reading these equations, which says to me our point on the coordinate plane is 0, negative 3. So we're going to go ahead and plot that, 0, negative 3. And the next thing I'm going to do, of course, is take my slope. The value in the equation is 4. I like to write that in rise over run, remembering that any whole number is simply a unit fraction over the value 1. So these are both positive values. I know when I'm done, my rise should be going up to the right. So I'm going to count up 1, 2, 3, 4, putting me at 1 on the y-axis, but I can't forget that we have to run 1 unit. We rose 4, and we ran 1. This is as simple as slope is. Rise over run. So we're going to graph that line. That is the worst line I've ever drawn in my life. That is the most crooked. You guys will forgive me though, because you know I'm trying hard. So there you have it. We've plotted our y-intercept. We used our slope up 4 over 1 to get to the next point on the line. We can do the same thing again. Up 4 over 1 should put us right back on that line. So you guys please try, check it out, 3, A, B, and C, and bring those solutions to me so I can check them. So if you look at example 4, we usually have a consumer application, and we want to talk about the meaning of the slope and the meaning of the y-intercept while we're doing this. So if you'll look at this example that we have here, Closet Organizer charges a $100 initial consultation fee plus $30 per hour. This is where we see something rising $30 every time we run 1 hour, remembering that time is always our independent variable. The cost as a function of the number of hours worked is graphed below. What we want to do is be able to write the equation that represents the cost as a function of the number of hours. Remember our lingo. We always say y is a function of x. So we want to write a function cost is a function of hours. So we know something's going to happen to hours, and if we look at our graph below, we see our y-intercept. So let's think of our equation y equals mx plus b. We know b to represent our y-intercept. So I would hope that everybody could agree with me that that b value should be 100. All we have to do now is figure out that slope. Well, if we go back to our little story, our explanation of what we're graphing, we see the rate of $30 per hour. And if I check on here, every 1 hour, I believe, is 1 block over. Let's check that and see if we can see. Yeah, every one of those is 1 block over. So if we went up, that would be 50. We would go over, that would be almost 1.5. Let's find another point on the line, however. So from 100, if we went up 150, that's positive 150. We are over 1, 2, 3, 4, 5, over 5, and that is indeed the slope that we see up in the story. We are going up $30 every time our function increases by 1 hour. So we can get the slope from our graph up 150 over 5, or we can start to realize that that information typically is given in any of the word problems that we're dealing with. Please go ahead and try, check it out. 4. There's only one problem there, and come back to me, check it out. Number 4, and show me your solution. When you're done with that, I would like you to do these problems. We are going to be working on page 272, and we're working on problems 14 through 31 and 35 through 44. That's lesson 4.6. And look for a quiz on Canvas in your quiz section.